Hey friends, greetings and welcome. We're talking today about solving quadratics by completing the square, right? So first of all, you guys are probably like, I don't know what it means to complete the square. Good news, I'm going to teach you. That's fine, because you don't know what it means to complete the square. It turns out it's going to be related to our perfect square trinomial pattern. Do you guys remember that?
No, let's hear it.
I think I remember that.
Let's see, the perfect square trinomial pattern was the a squared plus 2ab plus b squared, and that was equal to a plus b all squared. All right. So, also there was the variation where if this was a minus sign, then this was a minus sign. So let's consider the following. So consider. All right, this is going to be what we're doing. Let's actually expand something first. What would I have if I had x plus, I don't know, I'll call this c, let's say, all squared. What would I get when I expanded that if I went from this side to that direction?
X squared plus 2. Okay, Colin, you can do it. I don't care.
XC plus C squared.
Right? You guys agree with that?
No, well I do, but I don't know why because.
So this would simplify to being x squared plus 2cx plus c squared. All right? So what I am wondering, let's use that fact to solve this little mystery. What if I had this? What if I told you x squared plus 10x and then some number was equal to the following, x plus 5 all squared? What would have to go in that slot? 25. How did you know? Okay, so you recognize that this was b, and you were like, okay, so here would be 5 squared, right, and that would be 25. I agree. What if I didn't tell you what this was? Could you figure out, using only this side, how would you have gotten 25? Okay, so he said divide 10 by 2, and I would get 5, and then
Well, 10x.
well, he's looking at this specifically. Well, let's look at, because what we're comparing is how could I go from this coefficient to this constant, right? How could I go, because the 2c would be my 10 here. So if I divide 10 by 2 and get 5, I just found out what c is equal to. And then what could I do to that to find out what goes here? Square it, right? You guys agree? So it turns out I can find my c term, all right, that would give me a perfect square trinomial by taking my b, dividing by 2, and squaring it, right? So this would equal 25, right? And plus 25 would go in that slot, just like that. And that process is what we consider the completing the square process, okay? Where I'm trying to find out, okay, here's what I've got. What could I do to this to give me a perfect square trinomial? What would complete this perfect square trinomial, okay? So that's the idea. So let's actually do some examples of completing the square. Let's see. Complete the square. Okay? Let's do a few of these coming at you. What if I have x squared plus 6x? What if I have x squared minus, let's do, 14x blank. What if I have x squared plus 5x? Ooh, interesting. And last one, we'll have x squared minus a half x. Aha, all right. So complete the square. So the rule was to find the new c term. All right, so the new c was equal to what? B divided by 2 and squaring it, right? Is how we find our new c term. Right? So, for this problem here, what is b?
Yeah, 6.
6. So my new c term is going to be 6 divided by 2 and squared. So that's 3 squared, which is 9. So adding 9 would give me a perfect square trinomial.
C equals just makes a small case.
Sure, yeah.
Wait, let me
Very
just
happy.
write that down.
Well, while you're writing that down, let's consider this
Why not,
next
right?
one.
No.
X squared minus 14x. So how would I find my new c term?
49.
Whoa, whoa, whoa. Now you're the one rushing ahead. Whoa. Right? So what I would do is I'd take the b, which is negative 14, I'd divide by 2 and square it. So that's negative 14 divided by 2 is negative 7. And negative 7 all squared is positive 49.
Paul did it.
Yes, you did. You were faking being like behind, and then you're like, haha, I tricked you. It's like if we were in a race against each other to find out who was the best.
Oh, man.
And you're like, oh, my ankle, Mr. Waddy. And I'm like, oh, what's wrong? And then you're like, psych, and then like run past me, and I'm like, oh, what? That's what you did.
My little brother when we were little. And
Oh, wow. And you're still doing it to this day, making me cry. I see how it is. All right, let's keep going on, guys. What's the b on this next one? It's 5. 5. So to find my new c term, 5 divided by 2 and squaring it.
What? What's 5 divided by 2?
Doesn't matter. It's 5 halves. Now, it could be 2.5, and you could square 2.5, but gross, guys, decimals, yuck. Let's just deal with it this way. I can distribute this square to the top and bottom. 5 squared is 25. 2 squared is 4. So 25 fourths. All right. It's a little weird, but that is the thing that completes the square. It makes it a perfect square trinomial. It's the one thing that was lacking to be perfect.
How do you divide a fraction?
Oh, and here's the next question. How do we divide a fraction? So I'd have to take b. b is negative a half, right? So negative a half divided by 2 all squared, right? And how do I divide a fraction? Well, I could multiply it by the reciprocal of the denominator. What is the reciprocal of 2 over 1? 1 over 2. All right, so I'm going to write this out a little bit more than I have to. But multiply by the reciprocal of the denominator is a half. And what's negative a half times positive a half? Negative a quarter. Yeah. And if I square that, well, let's see, squaring the entire thing is going to make it positive. And now I'll just square the top and bottom. 1 squared is 4 squared is 16. Right, so I would add 1/16. So the other shortcut that I use is dividing a fraction by 2. You could just double the denominator. Double the denom. Am I right? Mm-hmm. There's a nice little shortcut for you, just in case that happens a lot. Notice, because it's always squared, notice my new c term, positive, positive, positive. It's always positive. Isn't that great? How positive it is. Now question, next step, what if I wanted to factor these super quick?
You do that.
Oh, but I do.
You do not.
But I do. Now if I factor those, it's just going to be a plus or minus b all squared, right? So as long as I know what a and b are, I should be able to factor that super quick. So let's see, a in this problem would have been the x. Actually, all of them will always just be whatever your variable is. So this is going to equal x with what all squared?
9.
Plus 3. How'd you get that plus 3 there? Yeah, that's the value of the... Now this is really tricky. This b was referring to the coefficient of your linear term. This b is referring to the pattern, whatever squared is equal to your c term. All right? They really should have chosen a different name for these variables, but that's what we got. All right, so x plus 3 all squared. 3 came from the square root of 9. All right. What is this one factor to be then? X with a what all squared? And, oh, this one will actually be a negative 7. And we know it's a minus sign because of this minus sign, right? Okay, what would this one be, you think? Ooh. X with it'll be a plus sign. It'd be the square root of this number, right? Square root of 25 is 5, square root of 4 is 2. Okay. And how about thoughts on this one?
X plus 1/4.
Well, it's a 1/4, but because of this sign, it'll be minus.
It was a negative 1/4.
Yeah, negative 1/4, yeah.
So,
So minus a fourth. Yep. Now question, looking at these, how many ways can you tell me how to find that number?
can't remember.
This plus 3, or this minus 7, or this plus 5 halves. Let's see, one way was square root that and take the sign from your b term. All right, so notice the square root of 49 is 7, take the sign from the b term. The square root of 25/4 is 5 halves, take the sign from the b term. The square root of 1/16 is 1/4, take the sign from the b term. That works. Does anyone see another way I could find that number?
Yeah, just take the B.
B divided by 2.
Okay, this number, is that the b you're referring to?
Yeah.
So positive 6 divided by 2 is positive 3. I like it. Negative 14 divided by 2 is negative 7. Positive 5 divided by 2 is positive 5 halves. Okay. And negative a half divided by 2 is negative a quarter. Does anyone see an even quicker way where that number could come from?
Just the thing, that thing, the words like -7 inside.
This negative 7?
No, the other one.
This negative 7?
Yeah.
Okay, let's see. Does that always work? 3 from 3, 5 halves from 5 halves, negative a quarter from negative a quarter. So that's the way that I actually find that when I factor it quickly, is I find it, good call by the way, other than the fact that your leg is on my desk.
Why? It's not even dirty.
Come
The way
on.
you find that is dividing B
Right,
by 2.
and that's exactly, so that's what I realized is dividing b by 2, we actually already did that math out. So I just take this number is whatever I had before I squared it when I was finding my new c term. All right, so this number is always going to be the b divided by 2 or the square root of the c term, right, or just this guy right here. So a bunch of different ways you can do that. So that's the idea of completing the square. That's step 1. So how am I going to use this when solving? Check this out, friends. Let's do a solve problem. Solve the following. What if I've got x plus 2 in parentheses all squared equals, I don't know, 9? Now,
What?
using yesterday's technique, you would have probably FOILed this out or used the pattern. You would have subtracted 9 from both sides in order to set it equal to 0. You would have then had to refactor it. It would have been a different answer because we introduced that minus 9 into it. And then it would have been set equal to 0, set each factor equal to 0, and solved. Now check this little trick out. Ready? This square is occurring to this whole thing. I currently only have one x. All right? How could I get rid of this square?
Square root.
Yeah. Let's square root both sides. Root, 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 root. And when you square root, plus or minus, don't forget it. when you square root both sides of an equation. That's right. Land on your right foot. Don't forget it. So the square root of this thing squared, the square root and the square would cancel out. And this is just going to equal x plus 2 equals plus or minus. What is the square root of 9?
3.
Okay, and now how could I solve for x?
Subtract 2.
I like it. Well done. So I've got two answers here because of the plus or minus. One of them would be, I'll write this step out, normally I won't, negative 2 plus 3, and the other is negative 2 minus 3, right? That's what plus or minus means. So here I'd have x equals 1, and here I'd have x equals negative 5. Normally I won't make you write out this step, okay? But I figure for the sake of our first time seeing this, let's throw it in the notes, you know, for the sake of obviousness. Obfuscation? Obviousness? No.
Obviously.
Obviousnessity. Clarity. So the trick is when you've got the square of a binomial equal to a number and you're trying to solve, just root both sides, kill that square. Bam. It's kind of nice. So let's combine these procedures to the following. Here we go. What if I want to solve this equation? X squared minus 6x equals, well, let's see. Now I'm going to do minus 40 equals 0. So let's say I want to solve by completing the square. All right, solve by comp the square. I'm going to kind of have like the little steps over here. So you guys already know how to solve this by factoring. You could also try to graph it and find the x-intercepts. Nice thing about completing the square works even when this problem is not factorable. This one happens to be factorable, but that's besides the point. It's going to be a nice introductory problem with friendly answers to us. But what I will do to complete the square is this. Step 1, we don't want it equal to 0. What? That is absurd. So
subtract 40.
we're going to move the old c.
Or yeah, add 40.
Yep. Good correction, good teamwork. So we're going to move the old c to the other side. All right. I like this. X squared minus 6x. And watch this. I'm going to have some really ominous foreshadowing blank right here. Equals 40. All right. Step 2, complete the square. Comp the square. Look at that. Bam. I even like drew a square there. It's kind of a sad looking square, but it'll do. So how do I complete the square here? What would go here? Well, let's find our new c term. That'd be negative 6 divided by 2, all squared. So that's negative 3 squared, which is 9. So let's add 9 here. Now, I can't just add 9 willy-nilly to a problem, okay? Because I can't, like if I add 9 to one side of this equation, it's no longer going to be equal because I just added 9. It would actually be this. So what's a solution I could do here?
Plus the 9 on the other side.
Perfect solution, my friend. Let's add 9 to both sides, right? Addition property of equality. Bam, add it to both sides. It's still equal, friend. What? So, behold. This right-hand side, 40 plus 9 is 49. This left-hand side, we know how to factor that. Super quick, in fact. I don't want you to even think that long when factoring it. That is going to be x with a what all squared?
Minus 3.
And where'd that minus 3 come from?
That thing.
Bam, right there. How awesome is that? What? Super awesome. Right? So I just want to point out that this guy can go right there real easy. Okay, so how do I solve this, though? Rutabaga. Root both sides, plus or minus. Don't forget it. So I will have, here we go, The square root and the square kill each other in a fight. It was very sad. X minus 3 equals, what is the square root of 49? Yeah, so plus or minus 7. And how do I get x by itself? Add 3. Oh, yeah. So I get x equals, two answers. 3 plus 7 is 10. And 3 minus 7 is negative 4. All right, so I just consider that plus or minus as two separate cases to get my two answers. How awesome is that, guys?
Sweet.
Yeah, it's not that bad. It's not that bad. Oh, actually, I think I forgot to write the rest of my steps. Let's see. So I completed the square. Is what I did. Step 3 was I factored, and I'll just say fast, right? So I don't want you to like, don't you dare start like finding the factors of 9, because I just made this a perfect square trinomial. We created the pattern, so it better fit the pattern. Just jump right into that. And then the last step would be root both sides. Root, and solve. And actually, it might not be a bad idea to write plus or minus on the root step. Don't forget it.
Hey, can I go, oh, is this?
No, we've got one more example I want to do. Just one more.
Yeah,
You can head out then if you'd like.
but I don't know if I want to do that myself.
Yeah, your call, your call.
I have to pee.
It's true. Let's see. Let's suppose I've got the equation x squared minus 7x minus 2 equals 0. All right. Let's do this one together. So, step 1, bring the old c to the other side. I'm going to do this one fast. And I'll have x squared minus 7x blank equals 2 blank. All right, I'm going to preemptively put that blank on both sides. Feel free to write these notes right on the side of your stomach if you, for some reason, wanted to remember them forever. Let's see. So let's find our new c term. Take the b is negative 7. Divide by 2 and square it. Ooh, guys, fractions. That doesn't divide. So let's just square top and bottom. It's going to be what, 49/4? So I'll add 49/4 to both sides. That completes the square. Right? So on the left, I'll start on the left this time. That fast factors to be x with a what all squared? With a what? Negative 7 halves. 7 over 2, right? And check this out, friend. Well, I'd have to find a common denominator there. What would I do? What is the LCD? It's 4. So I'd have to multiply this one by 4 over 4, right? So that's going to be 8/4 plus 49/4. Feel free to add more scratch work if you want. I guess I will here in this case. And that's, 57/4. And I always preemptively leave a little bit of a space here because I know my next step. Oh, 57, man. Thank you, friend. Got my back. Whew. Don't let that math gang up on me. We're a team. So let's see. Okay, so now what do I do? Root. Plus or minus. Don't forget it. So I will have x minus 7/2 equals square root of 57 over 4. I can break that square root top and bottom. So square root of 57, I don't think I can break that up. Square root of 4 is 2. And by the way, if the square root of 57 could be reduced, I should. If that was a negative, and I take the square root of it, what's this?
Take
I'd have to pluck an eye out of it. Yeah, what's wicked cool? It's completing the square can even find imaginary solutions. It's like a Ghostbuster. It's like finding all those invisible
No one likes the
ghosts. What is... All right, you did not just say that. Everyone loves the Ghostbusters. Except at the beginning of Ghostbusters 2 when they're doing the birthday party and none of the kids like them. How do I solve for x?
Add 7 to
Add 7 halves to both sides. And I get two answers here. X equals 7 halves plus or minus the square root of 57 halves. Now, I'm cool if you leave your answer this way. Sometimes you'll even see it written this way, where they combine them over a common denominator. And I want to point out there are two answers here, right? Plus or minus that number. So I could actually find a decimal approximation of this. Let's see, what's the square root of 57? And then divide that by 2. This is the same as 3.5 plus 3.77. And this one minus it would be 3.5 minus 3.77. So you could actually find the two decimal approximations if that's what you're looking for. I just typed it in wrong. 3.5, there we go. So this would be 7.27 is one of the approximations there. And 3.5, let's see. I'll just subtract that from both sides. Bam. Go to. What? What's this? 0.27. Nope, that'd be negative. Negative 0.27. Yeah. There we go. There. It's a little prettier. Not really though. But I'm fine with the exact solution up here. Notice how confident that equal sign it is, right? It's just like so sure of itself, no doubt. These ones are all like nervous and shaky and wobbly. They're like sweating from their armpits and like stained their shirt. Oh man, it's terrible. It's embarrassing. Rounding, please. So that is the general concept for solving a quadratic by completing a square. I hope you enjoyed it, friends. Bye-bye.